Okay, so moving on, we're now going to review the counting rules. Our basic rule is typically, informally, it's called the multiplication rule. It's when you have a number of events and each event has a certain number of options. To find the total number of possibilities, you just multiply out all those options. So let's look at an example. And then just to use this rule, some keywords is typically they'll use digits, letters, passwords, license plates, those types of problems. So our example is find the total number of code words. In this case, we're using code words, right? So that's going to let us know to use this rule. If the first three characters are digits and the last two characters are letters. Also, whenever you're repeating items, that's also an indication that we're using this rule. So remember, digits, there's always 10 digits, 0 through 9. And since they're repeated, we have 10, 10, 10. Now, the last two characters are letters. So there's 26 letters in the alphabet, but they're not allowed to repeat. So you have 26 choices for the first letter. One of those letters will occupy that position. So only 25 choices for the last letter. 650,000 different code words. For our next rule, remember that a permutation is an arrangement of objects. And if we have n distinct or different objects, we're going to calculate this permutation by computing n factorial. And how do we know when to use this rule? When we're arranging objects in a straight line. Repetitions in this case are not allowed, and order matters. So let's say that 6 people are lined up at a deli. How many different lines can be formed? Well, 6 factorial is 720. What if we want to find the permutations of objects around a circle? Well, in that situation, we have to assign one of those objects to the beginning and ending of a circle. Unlike a line, a circle has no beginning or ending. So this factorial is computed by taking n minus 1 factorial. So if 4 people are sitting around a table studying, how many ways can we arrange the different sitting orders? Well, you just take 4 minus 1, 3, factorial is 6. And then what if we're not using all the items for a permutation? Well, we're only using a portion of those items. Well, this is when we use this formula here. It's NPR, n choose r, is n factorial divided by n minus r factorial. So order is important. When do we use it? When we have prizes that are different. You have some type of race. You're looking for the top 3 or 4 people to finish the race. You're arranging a portion of items. So let's look at an example. Party is offering 3 different prizes at a party of 20 people. How many different ways can the prizes be awarded? Well, you have 5 people well, let's take a look here. So let's rework this. So we have how many people at this party? Actually 20. So there's 20 people at the party. So we're going to correct this problem here. 20 people at the party. And we're going to calculate 20p3. So I use a calculator. You don't have to rely on these formulas. You are allowed to use a calculator to compute these probabilities. And I do have some videos posted on how to do those types of calculations. So first we type in the 20. Then we type in our PRB. And then we type in 3. So the answer is not 60, but 6840. So there's 6,840 different ways to award these top 3 prizes to the 20 people at the party. Now we also have combinations. That's when order doesn't matter. So there's ranking is not important. We just have groups, and it doesn't matter who's first or what object is first in the group. Actually, that's combinations down here. We'll come back to that. This right here is total number of permutations when we have repetitions. Sorry about that. So this is repetitions. So what we do is we count up. So we count up all the number of items. That's going to be the top factorial. And then we just count the number of repetitions of each item and take the factorial and multiply them out. So for example, if we have the word committee and we want to look at all the permutations, well, first of all, there are 9 different letters, or 9 letters. If the letters were different, the answer would just be 9 factorial, but they're not. So what we have to do is we have to look at each letter and count all the repetitions. So C repeats 1 time, O repeats 1 time, M repeats 2 times, I repeats 1 time, T repeats 2 times, E repeats 2 times. We plug that into our formula, and I usually calculate the denominator first. So if you multiply that out, we get 8. 9 factorial divided by 8 is 45,360. Now going back to combinations, here in combinations, that's where order doesn't matter. We're just looking for groups of items. So, and some of the key words was when you have committees. Committees, there's no real order to a committee. Just any type of straight selection when you're selecting objects, and there's no order involved. So let's look at a problem. A committee of 9 people is to be formed from a pool of 28. How many combinations are possible? Well, that's 28, C9. Let me just verify this. So it looks like a pretty large number. And yes, that's correct, 6,906,900. And then sometimes the problems will have different categories, and you have to compute the combination for each category. So let's look at a problem here. It says a public safety committee is to be formed. There are 10 local residents, 9 policemen, and 6 politicians who wish to be on the committee. How many committees are possible if it must have 3 local residents, 2 policemen, and 1 local politician? Well, we do our computation, 10C3, 9C2, and 6C1. Perform the calculations. We get 120, 36, and 6. And multiply this out to get the final answer, which is 25,920. Thank you, folks. We are done with this